this question, we have a curve which we have to for which we have to find the derivative, the double derivative, and the integral. To find the derivative, we make sure that our expression is in the numerator, so we write it as 2 multiplied by 3 minus 2x to the power minus 2 minus x. Differentiating, we get dy dx is equals to, so the power multiplies with the coefficient, this will become a negative 4 into 3 minus 2x, and we multiplied by the derivative of this function 3 minus 2x, which is minus 2. The power decreases by 1, so it becomes a minus 3. Differentiating minus x, we get a minus 1. So the simplified form will become minus 4 times minus 2 would be positive 8. So we can write this as 8 divided by 3 minus 2x to the power 3 minus 1. For the double derivative, we differentiate the dy dx that we got over here. So we will multiply the minus 3 by minus 4, which will become a 12 into 3 minus 2x. The power decreases by 1, so it becomes a minus 4. And we again multiplied by the derivative of 3 minus 2x, which is minus 2. And the derivative of minus 1 is 0, so it will become a 0. So the answer would become minus 24 over 3 minus 2x to the power 4. To integrate the function, so the last thing is we have to integrate the function y. So again, we'll bring it in the numerator. So this will become 3 minus 2x to the power minus 2. Now, when we are integrating, we increase the power and then divide by the new power. So this would become 2 multiplied by 3 minus 2x minus 1. When we add 1 over here, so this will become a negative 1. And we divide by the new power, which is minus 1. And we also divide by the derivative of 3 minus 2x, which is minus 2. Integrating minus x, we get minus x square upon 2. And we always put a plus c if we have no limits. So the negative signs will cancel out. The 2 will cancel with the 2. We can write a final answer as that the integral of the function y is 1 over 3 minus 2x minus x square upon 2 plus c. Now in the next part, we have to find the x coordinates of m. Now, as you know that m is the minimum point on the curve. So on that point, the dy dx would be a 0. So first of all, we can start off by writing that the dy dx would be a 0 for the minimum point m. The dy dx was 8 divided by 3 minus 2x to the power 3 minus 1 is equal to 0. Taking the 1 on the other side, we get 8 upon 3 minus 2x to the power 3 is equals to 1. Simplifying, we get 8 is equals to 3 minus 2x to the power 3. Taking the cube root on both the sides, we get 2 is equals to 3 minus 2x. So we can bring the 2x on this side, and this will become 3 minus 2. So x would become 1 upon 2. So this is the x coordinate of m. In the last part, we have to find the area of the shaded region bounded by the curve in the coordinate axis. So we have to find this region. We know that the value of m is 1 upon 2 and the lower limit is 0. And we already have the integral of this function. So to find the area, we use the integral, which is 1 upon 3 minus 2x minus x squared upon 2. And we also have the limits, which is 1 upon 2 and 0. So substituting 1 upon 2 into the equation, we get 1 upon 3 minus 2 into 1 upon 2 minus 1 upon 2 whole square, which is 1 upon 4 upon 2 minus, we'll substitute 0 into the equation, we get 1 upon 3 minus 2 into 0, which is a 0, minus 0 upon 2, which will be a 0. So this 2 and 2 will cancel out. We get 1 upon 3 minus 1, which is 2, minus 1 upon 8, minus 1 upon 3. Simplifying, we get the area is 1 over 24.